Use the theorem of Pappus to find the exact volume of a general cone created by rotating a triangle with vertices 0, 0, 7, 0, and 0, 8 about the y-axis. I've already plotted the triangle shown here on the coordinate plane. One vertex is 0, 0. We have a vertex at 7, 0, and a vertex at 0, 8. Notice if we rotate this region about the y-axis, we get the solid or cone shown here on the right. Our goal is to find the volume of the cone using the theorem of Pappus, but we'll also verify the result using the volume formula for a cone, which is 1/3 pi r squared h. Let's review the theorem below. The theorem of Pappus for volume states, let R be a region in the plane and let L be a line in the plane that does not intersect the region R. In our case, the region R is the triangular region, and the line L is the y-axis. Then the volume of the solid of revolution formed by revolving R around L is equal to the area of R multiplied by the distance d traveled by the centroid of the region R. To find the volume using the theorem of Pappus, we need to find the area of the triangle, then find the centroid of the triangle, then determine the distance the centroid travels when rotated about the y-axis. This began by determining the area of the region R, or the area of the right triangle. Which is equal to 1/2 base times height, which is 1/2 times the base of 7 times the height of 8. The area of R is 28 square units. Next, we need to determine the centroid of the region R, or the triangle. The centroid of a triangle is the point of intersection of the three medians. Or physically, if we think of the triangle as a thin plate of metal and turn the triangle horizontal to the ground, the centroid would be the point at which the triangle balances. The shortcut to determining the centroid of a triangle is to determine the average of the x-coordinates of the vertices, comma, the average of the y-coordinates of the vertices. Which means in our case, the x-coordinate of the centroid is equal to the sum of 0, 7, and 0 divided by 3. And the y-coordinate is the sum of 0, 0, and 8 divided by 3. Which indicates the centroid of the region R, or the triangle, is 7/3, 8/3. Let's go and approximate this point on the coordinate plane, which should be approximately here. Next, we determine the distance d that the centroid would travel when rotated about the y-axis. Notice if the point is rotated about the y-axis, we would have a circle at which the radius would be this distance here, which is 7/3. Distance around a circle is equal to the circumference of a circle, which is equal to 2 pi r. Which means the distance d that the centroid travels when rotated about the y-axis is equal to 2 pi r, where r is equal to the x-coordinate of 7/3. This gives us 2 pi times 7/3, which equals 14/3 pi. Which indicates, using the theorem of Pappus, the volume V of the cone shown here on the right is equal to the area of R, which is 28, times the distance d, which is 14/3 pi. Which gives us 28 times 14/3 pi. The exact volume is 392 divided by 3 pi cubic units. Let's verify this result using the volume formula for a cone, which is the volume V equals 1/3 times pi r squared times h, which is really 1/3 times the area of the base times the height. So looking at the cone on the right, notice the radius r of the base would be 7 units, and the height would be 8 units. Which means the volume, using the volume formula, is 1/3 times pi times the square of 7 times the height of 8, which does give the exact same result of 392 divided by 3 pi cubic units. Verifying, we applied the theorem of Pappus correctly. I hope you found this helpful.